Hi everyone. In this session I'm covering a bit of theory on sampling, and then there is a separate one that looks at applying sampling methods. Right, now first of all, let's just have a quick look at the outcomes for this session. First of all, you should know the definitions, really important. Secondly, you should be able to state the purpose of sampling. Then you should be able to identify and state possible errors encountered with sampling. Then perform each of the sampling techniques, which I said is the next session, and then state the purposes of probability and non-probability sampling techniques, and then lastly name at least one advantage and one disadvantage of each probability sampling technique. Now for this session there's not really that much to explain. It is fairly self-explanatory. It's really just a few definitions and how they fit together. So if you want to read this section on your own, then you should have no trouble in understanding what is happening. Right, let's continue. First of all, when we want to perform a research experiment, whether we are collecting data using surveys or observation, regardless how, first thing we have to ask is who do we want to generalize the results to? Now, we call that the theoretical population, and that's just all elements that have the characteristic that you wish to study. Now, in my image here, I have the population of a country, but the theoretical population doesn't necessarily have to be people. It is literally all elements with that common characteristic that you wish to investigate. So it can be inanimate objects as well. Secondly, what population can we get access to? Because even if we are interested in the entire population, we can't select people from the entire population or objects from the entire population. So we have to look at what we have access to, and we call that the study population. So that's the actual set of observations from where we will select our sample. Then the next question is, how do we get access to it? And we call that the sampling frame, and that's nothing but the plan that we're going to work according to. And then lastly, who is in the study, and that will be the actual sample. So that's the subgroup of the population that we select from the study population. Now, two other definitions that we need to consider just for the sake of completion. We won't be looking at it in detail. That is the matter of a census. Now, a census is when we actually are able to collect data from the entire population. So in other words, our sample is actually the entire population. But that is a really expensive exercise, so it is not done on a regular basis. Then secondly, what is a poll? A poll is a survey where the topic is usually political of nature. So we ask people questions and we want to know their opinion on something, and that something will be political usually. Right, now let's have a look at the process in a little bit more detail. First of all, what is sampling? Well, very simple. It is selecting a subset or a subgroup from the population. Now this can be done with replacement. In other words, where we would select something, an object, an element from the population, observe it and then put it back, and then there's a possibility that they can be selected again. So that's with replacement. And secondly, without replacement. So that means the sample that we collect will be unique. Nothing in there will be repeated. Now, graphically, we will have our population. Now remember, we have the theoretical population, which is everybody or everything. Then we have the study population, where we actually select from. The subset will be coming from that population. Now always we denote the population size by capital N and the sample size by lowercase n. Now, why do we sample? Simple reason, it is cost effective and practical. We wish to know more about a population, but we can't afford to study the entire population, so we select the sample from the population. However, we have to keep in mind that the sample must be unbiased and representative. In other words, it must be a true reflection of the population. So if we have many different elements in the population, then we should have representation in the sample for those many different elements. Once we have that, then we are able to generalize, or in other words, extend or infer the results that we get for our sample to our population. So that's the main reason why we want an unbiased representative sample, so that we can draw valid conclusions from the sample regarding the population. Now, when we work with the population, then the values that we calculate, the numerical summaries, things like averages, we call those parameters. So population parameters describe the population data, whereas with a sample, we call those summary values, we call them statistics. So statistics will be the ones that we actually calculate, and we wish to use them and generalize those results to the parameters. So in other words, if a statistic has a certain value, then we should be able to say that the parameter will be very similar to that statistic's value. Now I'm saying similar because statistics are estimates. Remember, statistics is calculated from a sample or a subset, but if we have different researchers studying the same population, then each one of them will select a different sample. And because they have different samples, the estimates for each of the samples will be different. However, if the samples are unbiased and representative, then although the estimates or the statistics are different for the samples, they should still be very similar to the actual population parameters, which are the population values. Now, the sampling takes place in two ways. We either have a probability sample or we have a non-probability sample. All sampling will be divided according to those two. Now, first of all, probability sampling. That simply means that all the population elements have a chance of being selected for the sample. They might not have equal chance, but all population elements have a chance of being selected. On the other hand, non-probability sampling means that not all the elements have a chance of being selected. So there will be some criteria that will exclude certain population elements from being selected. And this is looked at in the definitions of the different non-probability sampling techniques. Now, under probability sampling, we have four main methods. Simple random, which is the most common one, random cluster, stratified, and systematic. And this is covered in a little bit more detail in the next session. Non-probability will have things like convenience, judgment, quota, and snowball, and the definitions for each one of these is given in the next section as well. Collecting data can happen in a few ways. We can have surveys, observations, or experiments. Now, a survey is exactly what the name said. You probably have been the subject of a survey. It is simply where you are being asked questions, where somebody has a questionnaire, and according to what you answer, they will complete the questionnaire. Observations. So here, the researcher simply observes, and usually they don't interfere. Experiments. This is where we have a procedure or a series of procedures that's designed by the researcher, and it can also be controlled by the researcher depending on the type of research that's being done. But this is more hands-on, whereas observations is an outsider's perspective. Now, very, very important is this definition of an error when it comes to collecting and representing data. In statistics, when we talk about an error, it is not a mistake that we are referring to. Now please take note, an error in statistics is not a mistake. An error refers to the difference between the actual result, in other words the true value, and the result that we get from the experiment. Okay, so in other words, an error will be the difference between the true value, in other words the parameter, and the result of the experiment. Right, so we can think of the experiment, if everything is perfect with the experiment, then we will get no error, because then the experiment result will be the same as the population result. Just a simple example, if we think of flipping a fair coin, in other words, there's a 50% chance of getting a head and a 50% chance of getting a tail. If we flip that coin 10 times, then in an ideal situation, we should get 5 heads, 5 tails. But because there are other factors affecting the experiment, such as the strength with which you actually flip the coin, and maybe the angle at which you hold the coin. So all of those things that we don't always realize can affect the experiment. We might end up getting 4 heads and 6 tails. Right, so the difference there between the actual result and the experimental result will be an error. Next is reliability. Now, reliability is simply how consistent the results are, or how consistent the measurements are. So if we perform the same experiment a number of times because of uncontrollable factors that affect the experiment. We won't get exactly the same result every single time, but if we have high reliability, it means that the result should be fairly similar. Validity is the extent to which one can draw meaningful conclusions from the data. In other words, the validity looks at whether the experiment or the observations or the surveys, whether it actually addresses the issue that you intend to research. So, is the experiment valid or not? Graphically, you will always see this type of image associated with reliability and validity. If we look at the target and we think of the center of the target as being the main objective of the research and the dots as being the experimental results, then the first image indicates high reliability because all the experimental results are very close together, so they're very similar to each other. However, they are not valid. If we look at the second target, then we have low reliability because the experimental results are spread out more than in the first one, but now we also have low validity because they start to center around the main objective, whereas this one is completely off topic. Over here we still have no validity and we don't have reliability either because it's too spread out. The last one, however, we have very good reliability, so very high reliability and very high validity, because the main issue that we wish to investigate is actually being addressed, so that's high validity. And secondly, we have all the results very close to each other, so that's high reliability. Now, if we look at errors that can occur in sampling, then there are two types of errors. We have sampling error and non-sampling error. The sampling error can be due to a random selection. Remember, if a selection from the population is completely random, then everything or everybody has a chance of being selected, regardless of how small that chance is. So we might end up with a very odd-looking sample compared to the population. Now we can overcome that error by increasing the sample size, because then we're selecting more elements from the population, so the sample should become more representative of the population. Right, for non-sampling error, we have non-response bias. I'll look at that definition in a moment. We have human error, which is a very common one, and that cannot be overcome by increasing the sample size. Right, the two definitions that associates with this, first one is selection bias, which means we have an unrepresentative survey. Right, selection bias, so we're not giving everybody a fair chance of being chosen, or everything. And then the next one is non-response bias. So this is where we have very obvious and glaring differences between the groups of respondents. And the distortion of those views we'll call non-response bias. Now a typical example of this will be if we conduct a survey regarding customer satisfaction. Usually, if customers are satisfied, then they won't have much to say, right? They will be very reserved in their opinion. But unsatisfied customers will have the most to say, and you won't be able to keep them quiet usually. Right, so that's a typical example of non-response bias, where the one group is dominating compared to the other group. Right, now finally, we have advantages and disadvantages of the different sampling methods. But that I will leave to you for self-study, and there will be a quiz with a few questions on this.